Germany, a nation known for its groundbreaking technological feats, is now at the forefront of a nuclear revolution that could completely change the future of our entire planet. The fact that Germany was the first country to abandon nuclear energy has led to an unexpected yet enlightening outcome. The ongoing war in Ukraine and sanctions against cheap Russian gas have pushed the country into a severe energy crisis, posing challenges to the country's economy and calling into question its nuclear phase-out. However, though Germany is phasing out nuclear power, the nation is still leading in nuclear technologies. And now it is witnessing the dawn of next-gen nuclear technologies with its latest Thorium Reactor breakthrough. Introducing the Dual Fluid Reactor, a groundbreaking new thorium molten salt reactor design that is game-changing for several reasons. While traditional nuclear plants use a more than 50-year-old technology based on uranium, the next generation of nuclear reactors is harnessing thorium, an element much more powerful and abundant than uranium. With only 1 ton of thorium, it is possible to generate the same amount of energy as 200 tons of uranium, and a dangerous meltdown is physically impossible. But what makes this new reactor truly amazing is the fact that it can burn nuclear waste. And by untapping this resource and commercializing nuclear waste, this new thorium molten salt reactor could supply our entire world with clean and safe nuclear energy for up to 1,000 years. So what is this new reactor all about? How does it work? And what does it mean for the future of our planet? We have everything you need to know covered in this video. Germany was once home to the most powerful and efficient nuclear reactors. However, the risk of a nuclear meltdown, as well as the repository problem of nuclear waste, led the country to shut down its last active reactors. But the sanctions against Russian gas, and ironically, the decision of Germany's Environment Party, has resulted in the country putting coal-fired power plants, the most polluting fossil fuel source, back into operation. Additionally, Germany now had to rely on energy imports from neighboring countries like France, which generates over 60% of its energy from nuclear power. So while Germany was still dependent on nuclear power, its economy began to crumble due to expensive energy imports. This is a perfect example that a baseload-capable renewable energy grid is not possible with solar and wind alone. Fortunately, the next generation of nuclear reactors are an excellent option for safe and clean nuclear power supply. So how does the Dual Fluid Reactor work? Traditional nuclear plants work through nuclear fission, where uranium atoms are bombarded with neutrons, causing them to split and release tremendous amounts of energy, leading to a chain reaction in the fission process. Continued release of energy heats water, creating steam that drives turbines to generate electricity. But while traditional nuclear plants use solid materials as fuel rods, the fuel is dissolved in a molten salt mixture for use in a dual fluid reactor. Dual fluid means 2 fluids form the plant's core. One contains the fuel, and the other acts as a coolant. Any fissile materials can be used as fuel, from conventional materials like uranium to thorium, and even nuclear waste. The liquefied fuel is delivered to the power station in a sealed cartridge. It is then heated and pumped into the reactor, generating even more energy as the fission process begins. The liquid lead flows in an entirely separate chamber close to the reactor core to extract the heat efficiently. The lead then carries the heat to a separated turbine loop to exchange heat again for the energy generation process. So the dual fluid reactor can not only harness thorium, which is 3 to 4 times more abundant than uranium, but it can also turn nuclear waste into electricity, which is groundbreaking for several reasons. The main reason is that current nuclear plants produce high-level nuclear waste, which remains radioactive and hazardous for more than 100,000 years and has to be disposed of properly. In 2023, the United States accumulated about 88,000 metric tons of highly radioactive waste. As there are still no plans for managing and disposing of spent nuclear fuel, the nuclear waste in the United States is piling up in those plants, leading to a huge safety problem. However, by utilizing nuclear waste as a resource instead of managing its disposal, this new technology could supply the United States for up to 1,000 years with cheap, clean nuclear energy. And that wasn't even all. According to the company, the liquefied fuel can operate for about 25 years. But at the end of the burning cycle, the spent fuel is transported to a recycling facility, where still fissionable materials are returned to the reactor to be burned again, significantly increasing fuel efficiency. The residual radioactive materials become less harmful than natural uranium in 300 years. Furthermore, the new reactor is considered extremely safe, and catastrophic meltdown situations like Chernobyl and Fukushima are physically impossible. The reactor can never overheat, as the laws of nature work in its favor. If the temperature increases, the liquid fuel expands. As a result, the reactivity of the fission process automatically decreases, creating a self-regulating feedback loop. An additional safety feature enables using this reactor even in hazardous regions such as earthquake or tsunami areas, typically unsuitable for nuclear power plants. There's a melting fuse plug at the bottom. If the reactor overheats, the plug melts, and the liquid fuel drains into a separate passive cooling tank where the nuclear chain reaction stops immediately. According to the company, the Dual Fluid Reactor is incredibly efficient and delivers up to 20 times more energy than current nuclear reactors. Unlike traditional nuclear plants, which can take up huge spaces and take decades to build, the Dual Fluid is also designed as a small modular reactor, making it much more scalable and affordable. Just one of these reactors can power 500,000 homes, while several small reactor cores can be used to replace a large power station. With this new thorium reactor, German engineers have marked a major milestone for the next generation of nuclear technologies. I know what you're thinking. It sounds way too good to be true. So what's the catch of the story? Currently, the system is just a concept that has gone through many preliminary studies, but component tests have proven its feasibility. The plan is to develop the first test reactor by 2026. The prototype is scheduled to follow in 2029. And mass production is scheduled to begin by 2034. So in less than 2 years, we will know whether the system works. If you don't want to miss any updates about this progress, make sure to subscribe to this channel, where we discover the latest energy generation methods that will shape the future of our world and could also save your energy bills. Interestingly enough, the first test reactor will not be built in Germany, but in Rwanda. Bureaucratic hurdles and a lack of government funding are hindering the development of such innovations. However, innovations like the Dual Fluid Reactor are inevitable. That's because the importance of clean, carbon-neutral energy is significantly increasing in the global economy, while many existing nuclear power plants are reaching the end of their designed operational life. Updating, maintaining, or decommissioning these aging reactors presents technical, economic, and environmental challenges. Furthermore, conflicts like the Russian-Ukraine war led to a massive surge in energy prices and showcased European nations' reliance on Russian energy. The Dual Fluid Reactor would be a perfect alternative to decouple from Russian gas. It is a carbon-free energy source that is in high demand and a safe and clean alternative to conventional nuclear power plants. The success of this reactor could be revolutionary for the energy industry, but unfortunately, the United States is not supporting the fourth generation of nuclear reactors. Meanwhile, China has already launched its first thorium molten salt reactor, taking the lead in advanced nuclear technologies. Is China leaving the West behind? Click the displayed video if you want to find out more about China's thorium molten salt reactor breakthrough.